Mm. Okay, let's start the class. In the last video, we were seeing like how what is Docker and Docker architecture, and the basic Docker commands, and then like how we will write a Docker file and what are the parameters that exist in Docker file that we have seen in the last time. So, see, we probably ended up a similar file like this. So this is a sample Docker file. So we were seeing like from which image and labels, and then we were seeing like arguments, environment, and then work directory, run commands, add copy, entry point, and CMD. What I said in the last case, like arguments are actually passed at the build time. When you do build, if you want to change this app version, then you have to, in the build command, you have to pass that hyphen hyphen arg, and then you pass this value. Okay, what I mean, like, mm, this is my sample Docker file, right? So here I think I didn't save the file. If have arg here, mm, and then like build version is equal to 1.0.0, and then environmental is equal to like this build. uh, so you can see my argument is like build version 1.0.00 something. What I'm going to do is like I'm going to ask my chat GPT, hey, what happened to my files? Okay, this is my app.py. I'm going to ask ChatGPT to modify my website uh, to print the build version from the. See, what I'm asking to ChatGPT is like, uh, so this is my local code. When I run like run this app.py, this function runs, and in the local host 5000 port, I can see the application has been running. That's what we have seen in the last class. So I'm going to ask the ChatGPT uh, to have the build version from the environmental variable. Okay, so my environmental variable is like this. So whatever the environmental variable currently in the Docker file, so we can see that in the website now. So first, uh, let me copy this thing and then update my app.py. You don't need to worry about this app.py file. Whatever is there, let's find. That's like it's none of our business to update any of the application. Once you started working in the real time, you will to know you will be get to familiarize with the application flow, like how the folder structure of the application has been written, what are the files they will contain. Those things you will get familiarized once you started to work. So what I do is like um, I updated wait like mm, now what it will do is like it will read the uh, build version. If you see my Docker file, so in the argument I mentioned the build version is 1.0.0. This is hard coded instance. This value is written in the Docker file, and the build version file is from and it's from the argument the environmental variables file. It is getting fetched from the argument. I'm just doing a build now. Docker, I just wanted to Docker images, um, and then if I do Docker images, sorry, Docker Phoenix 1.010 is there. I will do what I'll do is like I'll do Phoenix 2.0 and then dot. So if I do this thing, so this time the build will runs. Oh, Mm. So this time the build will not take much time because it's already a lighter image and I have all the most of the images here. So it will try to compile as soon as fast. Like you see, it's done mostly. It's like exporting. If I run the application now, run docker run -d -p 5000 5000 and then like Phoenix 2.0. Okay, then the application will start to run. If I do docker ps, I will able to see the Sting application is running. Let me go to the browser and type localhost 5000. ah okay, it is not being replaced. So we can do the like debugging here. So if you do face any issues, just try to copy paste them from the uh, uh, from here. Okay. Oh, sorry. I think I pasted a wrong one. It should use shell. Uh, I think I was using wrong brackets here. It should be curly brackets. Because curly brackets means it consider it as a shell. If it doesn't mean it will not consider it a shell. That's the reason it has been failing now. So let me do it, like let me try to rebuild the application again. Mm, Let me go with 3.0 now. Do the build. Uh, so nothing has changed, so it will not take much time, I guess. mm, I'm on the do docker ps. One container is running docker, or am I funny off, and then give the container id. mm, the old container is deleted. Now I'm running a new one with 3.0. Let me go to the localhost now. If you see means like what do you see, the build environment is like 1.0.0, right? How it has been passed now. So you can see in the docker build command, I didn't pass anything. What it was there, it was as like docker build -t phoenix 3.0. So on the build version, or in from the argument it's mentioned 1.0.0, in the and it's taking from the shell. So and from the environmental variable my application has been written. So environmental variables for that in the particular environment, whatever the key value pairs that you want to set, that is called that's actually set in the environment itself. That is called environmental variables. So it is fetching the values from the env build version, and it's from the build version here. So what happens is like now what I want to do is like now I want to change the build version to something else. First what I will do is like first I will try to show you that going to build another build like 4.0. And but here what I will do, I will do build arg command, mm, uh, build arg, and then build version number is equal to uh, while building the application I am actually modifying this version. Okay, 1 point, like I will give like 2.0.1 something, I will give it, and then I do the build. uh, mm, and the build has been started now. Just I'm passing the hyphen build hyphen r and the param and the variable name that we exist in the docker file. So let's wait for it to compile, and then it's done. We triggered a 4.0 now, and then we will run the 4.0. Like before that, okay, let me show one thing. So let it run in the Python itself. What I will do is like the application from the 3 dot version is running in the port 5000. Let me the first port number we're mentioning is the low is the physical host, right? Let me run it in 5001 now. Then if you go to your local host, this is running from the version 3 and it is using 1 by like 1.0.0, and we have a version 4, where in the version 4 only, like if you see our build command, in the version 4 we passed the build version is in 2.0.1. Okay, now if I type 5001, then you see the build version is equal to 2.01. So this how each and every time the build number has been changed. Why I'm particularly concentrating about this arguments and environment, by using these arguments alone, for in every organization the build version is getting updated for the image. So even for the image, I'm just giving a 3.0, right? They will use a build version only. There was something called like semantic versioning. So each and every release they will be having some semantic version. Those versions they will be able to pass it from the pipeline, and they will increase the version from like 1.0.02, like 1.0.2 or something. That's how they do the incrementing things. So that's why I'm concentrating on here, like how if you want to increase the parameter from the build version or something, that this is how you should do now. So you know the build version, you from the build that you have been running, you passed in the Docker build, you passed the 2.0.1. Now what I do is like I do the same Docker run command which is running with 4.0, but now I'm going to pass something called hyphen e. Hyphen e means environment. Previously we see like hyphen build argument, right? In the build command we passed. Now this I'm not going to pass this value because here I know it has 2.0.1. Now I'm going to even replace that. Okay, now your build version 4.0 as build version called 2.0.1, but even want to replace that while running the docker run command. That's how I do it, like build version, and then I give it as like 3.0.212, and then I run the command. Wait, like okay, it is saying like port is been already used. Then let me use some other port called 5002 here. And then run the command. I think it should be the same. Oh, I should run it before the opening. Okay. So you should so each and every time you run, you keep remember like hyphen name, hyphen d, hyphen volume. Everything is before the image version. Okay. So only the image repo name and version should be in the last, and every other argument should be in the front. So if I run now, it started to run. If you see Docker PS, I'm running three versions. One is running with 3.0, one is running with 4.0 in the 5001 port. Now it is running in 5002 port. Now let me go here. Now copy like 5000 localhost and 5002. Now you see like it's coming. I think it's not replacing. So leave it. But that's how you actually replace the versions. Okay. Um, so any doubts on these arguments and environments?
Not this, I have a little doubt on this. Why they are changing?
Hello?
May, may we change? Hello, can you
Yeah,
hear me?
yeah, yeah, I can hear you.
Hello.
Yeah, yeah.
Why we are changing version? Is there any changes in programming or like that? So they are
Yeah,
updating the
yeah, yeah,
version.
yeah, yeah. That's the reason. Okay, so you cannot have the same version and have the application deployed in your repository or something. Repository is where we hold these images, right? It needs some versioning, so you can know from one version to another version what's the change has been happened. So in every organization, what I told previously itself, the versioning will be looks like this. The first digit points to the major versioning, second digit to minor versioning, and the third digit to patch versioning. So these things they will only decide, like application team will tell you, like this has to go in 102. They will tell you, okay. In the pipeline, most people's either they do semantic versioning. Semantic version means so somehow they started the versioning. It will go through whatever the versions that exist in your repository. It just go to a repo and see what are the versions already present, and it will do the increment of 1.0.02 1.0.1 automatically. Okay, or you have to pass this build version from your pipeline manually. See, that's how the build version has been passed. Okay, you should remember, always you should change the build versions. You got it?
Yes,
What?
yes, yes, yes.
Okay, okay, okay.
Okay.
um, and then next command would be, yeah, that's what I want to talk about, this arguments and environments. And the last command would be like entry point and cmd, that we discussed. The whatever the command that we paste in entry point, that cannot be replaced, but whatever the command that we paste in cmd, it can be modified at the docker run command. Okay, so entry point commands are actually placed at the image layer itself. CMD commands can be overwritten at the Docker runtime. So there was one more concept. So so most people will not be using this flow. Okay, this is a single Docker image. Okay, all the interviews will ask you what have you used multi stage Docker container. What that means? If you see my Docker images here currently, the Python should be here. Like okay, Python is not there. This Python 3.10 they addressed, right? How come it's not there? I think I deleted. Docker pull. Let me pull the image. If you see, currently our Phoenix project image size is like 209 MB. If you pull the I pull the image and then see Docker images, now see the Python version slim dot is like 192 MB. Okay, the base image for my Phoenix image is like I have 192 MB. On top of that, what we did is like we added some dependencies and then we created the image out of it. Okay, but in most organizations, either they will go with this slim version. Slim version is already been already some of the system libraries has been removed, and whatever for the Python application to run, whatever the libraries that need, that one those contents will be present only in the in the slim version. So but in the most organization they will not do it. What I will tell ChatGPT now, like let me uh, give it in multi-stage Docker content. I didn't add it in my slide, but I want to tell. So multi-stage means they will do the build dependencies in one image, and then copy those dependencies and libraries from there to the second image. This is how it looks. So I'll copy and I'll extend in local. Mm. Now you see, now there are two stages. One stage is to build dependencies. The second stage is final stage. Okay, so mostly this will not impact any of the image for a year, but in organizations, what they will do is like they will take any base images like Ubuntu or Alpine or any of the package where they have like supported system libraries and everything, and they'll do the building here. You see what happens here, like I take a Python 3.10.slim and just marking as builder. Okay, it's just an alias name, it's just a name. Okay, you can give any random name as a build, as a like a builder. You can give like a, you can give it as base or something, but uh, you can give anything, and then all the arguments are same, and until the build command will be present in the first image, run pip installed like recommend that text only up to this he will be there. And then uh, and then what they opened is like in the second stage, what they did is like you see hyphen what is they doing is like, so in the hyphen prefix, what it does is like it installs all the dependencies in this install folder, root install folder, have all the dependencies. Okay, and then from the this from the copy command, hyphen from is equal to base means it is copying from the base image. Okay, in the hyphen from is equal from is equal base means from the build image, and then install means from this image I know there is a folder called installed. Okay, in the root install there is the install folder, then I'm copying it to the user local folder, and then you copy your application file. This copy means copy the app.py and docker file and whatever the application data file, copy and paste it. So this is how the multi-stage docker container would looks like. So always try to say in interviews or something, that you have used multi-stage docker containers, and what's the use of it, like the main use of multi-stage docker containers to reduce the image size. So in the first image they will have the system, you will be installing all the system libraries, and then copy those libraries to the second image and run the application. I just do some docker build here. So it will not reduce size here because this application is already using very minimal packages and everything. Instead I think it will is going to increase the package, I guess, if I do docker images now. uh, 5.0, you see it got reduced. You see, previously the image size was like in the 4.0 it's 209, now it's at 198. The impact is very minimal, but in case of other real-time applications the changes would be from GBs to like with it's like 300 to 400 MBs. That's the example for this thing. Okay, let's move to, you got this thing right, multi-stage Docker container. Oh, I think I have the example here itself. So that is what the multi-stage Docker container means. And then uh, so regarding the image optimization, what I told, like in the first image, whatever they use, they will be using some default Ubuntu or Node 18 or any of the images, and then in the second image they will use, they will be going to specific images like from Alpine or from Slim build or distroless images. So these are the some kind of uh, packages that available for you in Docker, so which has less packages. So most probably you will be seeing this command as well. What is do like apt get clean and rm hyphen var lib apt list means. So I'll copy this command, then it will be. So what it means, like apt get clean. Somewhere we have seen this command. Like apt means whatever, whenever we want to install semi packages, what we do like apt install like Docker or something, right? Docker or any of the applications, Sonar Cloud or some Sonar Cube. whatever we do to the command. So this apt get clean means it removes the unwanted packages that are actually currently not used in your Docker image. So my goal, my motive of my Docker multi-stage is like to reduce the image size. So that apt get clean will remove the unwanted packages that are irrelevant to the application. And then this where the RMF and RF means like removes this is where most of the libraries is going to sit when an apt command is get executed. It will remove that images and libraries as a libraries there. So that's the use of this command. mm, you should be keep remembering like but no nobody will in interview will ask to write these things, but you just I want you to be aware. That's why I'm telling here. um, and you see something called trivi, right? For now just remember a word called trivi, and which is trivi means um, Trivi is like it's like a tool which is used to scan vulnerabilities. Once you build the images, you do execute a command called Trivi image and your repo name and the image, and you give the image. It will tell what are the vulnerabilities there in your image. So what is this vulnerabilities means? So you write a code, and there are a lot of standards that are available in the internet for any code to be written. And the Trivi is like a tool that is able to identify if there is any issues in the code or any package that need to be updated. Those things will be Trivi will get highlighted for you. But you just keep the remember word of Trivi alone. No need to like tell that you've been using Trivi or something. In the pipeline, they will integrate with Trivi to scan the images before they push to ECR. That's it you want to know for now. Okay. So and then Docker volumes. So we'll move to the Docker volumes now. What is this Docker volumes? Okay. um, if you seen like Docker, so if you see my Docker ps, mm, so Docker has been running like three containers are running here. uh, what will happen if this containers goes down? Like I do some Docker rm hyphen uh, first delete these two containers. Now do Docker ps. So now I am having the only one container running the 502. So if the Docker container is running, if in order for you to get inside the Docker container, there is a command called docker exe. Docker exe hyphen it, and then give the container id, mm, and then slash bin bash. Look at the command once again. Docker exe means executing, hyphen it means interactive mode, uh, and then you give the container id or the container name, and in the last on which shell you want to enter. Okay, if you give that, you will be able to re running error. That's not like issue, that is like so it's some issue with the terminal. Okay, so I've given like a slash sh, right? It's like a terminal, it has to consider it as a terminal, but it is considering it as a file path. That's the issue here. It always happens with the bash. So instead of using bash, you have to use cmd here. It will work. mm, Dr. exe hyphen id, and then I give, now I give the bin bash. I'm giving the same command. Now you see I'm inside the Docker container. Docker, when I do Docker ps, this is my container 26327 something. Now you see root at 26327 Now I'm inside the Docker container. What I will do is like if I do ls, you can see ls ltr. There are three files inside the Docker container. Okay, I'm inside the Docker container, and I add something called I create a file called demo.txt file. Okay, enter, and then Now if you type ls-ltr, and then I come out of a container by using exit. Now I'm come out of the container. If I do docker ps, still the container has been running. The file demo.txt is there. But do you think after I delete this container and recreate the container from the same Phoenix 4.0, this file is going to be exist? No. This demo.txt file will not be exist. That's why, because all the Docker containers ephemeral. Ephemeral means they don't have any space to storage. Unless you specify the storage, uh, it will not store any of the files. If one container goes down, the whatever the data that exists for inside the container will not be available. Okay, that's the meaning for that. Mm, if you do then what is the need of this docker volumes? Okay, this is my container. Okay, leave it. Uh, this is my container. My container is running here. This is called docker. Okay, and it is running in a physical machine. It is running in my machine. Okay, what I'm going to do is like, whatever the file you generate at this particular folder, uh, copy this file to the physical host. Okay, copy it to physical, sync it with physical host. Whenever you read in the docker container, you just specify the path. So the files was generated in the previous container will store to physical mount, and the next time when a new container comes up, it will get synced up with this physical host and gets the file inside the docker container. So let me explain it from the command, then you will know. Okay, now I do docker previous, if I do docker rm, and I and what I do now, like docker images. Okay, so what I do is like, I'm going to create a volume. Okay, uh, there are two types of volumes are possible. In like, either you create a volume, um, either you create a volume here, and then get attached to the docker container. So these volumes will be handled by the docker container itself, and the second volume will be physical host. Two types of volumes are possible. So let me explain the two types. Like, if I do okay, mm, now I give docker run command, um, docker run -d -p 5000 and 5000 Phoenix 2.0, and then I will give some Docker volumes. To mention the volume, you have to give like volume. Okay, hyphen v are like hyphen v are like hyphen volume. Both are fine. Then I give my current directory. Dot means current directory, and then um, no, I will give something called I'll create a folder here. I'll create it as store. Okay, I created a folder called store. Now I give dot store and then colon. In the application, I will be going to create an mm, in the application I will go. It has to be like slash app slash store. Why you are giving like slash app slash store means, here I know there is a store folder I created in the physical host. Whenever it is going to do this copy command, it is going to copy all the files and folders to the inside the docker container. That time the store folder will be exist in the under the slash app, because I set a working directory as slash app. Okay, now I done Phoenix something, Phoenix 4.0. Now if I run it, it started to run. If you do docker ps, uh, this is what we called physical host, because I created a folder here and I mapped that folder to docker container. uh, Here the file is going to come. Okay, now I'm going to inside the docker container docker exe -it, and then I give the docker container and then I give bin bash or something, and then I enter. Now I am uh, inside the Docker container. I go to the store folder, and then I create some file called um, tech uh, demo.txt, and then we demo.txt. Oh, we is not available here, man. No. Bro. What I'm doing is like I'm printing this command hello bro into moving this command to demo.txt file. Okay, it's done. If I do cat demo.txt file, now you see, uh, you see some contents, right, that exists inside this thing. Now if you see in the store, there is a file is there, right? Now I've come out of the container. Now if I open this thing, ps, ah, now you see 4.80 is exist, and I am going once into again the container to see the file actually exists or not. The store.exe, and then um, cat demo.txt, uh, file is there. uh, it should come out. Now probably we should see the file here, but I'm not sure why we're not seeing the file here. Did I made there is one more command. After you run the command, you want to see on what port you come, like um, your Docker container is running and everything. If you do Docker PS, you will get to know image and status and port and those things you will see. There's one more command called Docker inspect. If you do Docker inspect and then you give the container ID, it will give you the long details how the container has been started. So what is the IP? If you see, like you see a lot of JSON data here. So argument is like app.py, the container status is running. You will see a lot of status like what is the image it has been using, and what is the host it has been using, and see like dot store folder and app dot store folder, how the folder has been synced here. Those things you will be able to see here. That's the use of this docker inspect command. uh, and and then if you do docker logs means whenever you run an application, that application will print you something. Like that's how the code has been written to print something, how it has been compiled and which port it to start. Those things you will be seeing in the application logs. If you do docker logs and then the container ready, you will be able to see some logs. Okay, see the it started serving flask app, running on app, running on this particular port, something. So this information that you will able to see when you do docker logs. Now whatever commands you've seen, like docker exe -it command we have seen, and then docker logs contain id we have seen, and then we have seen the docker and then what is like docker inspect command. So that's the use of this docker come. The file should come here. I think it's not coming because the directory, it's a windows, some directory issues there. That's the reason we are not able to see this, because I mapped dot store, so it has some mapping issues. uh, that I'm aware. Let's what I do, like let me create a docker volume for you, like mm, I will create a volume. What I'm doing is I'm creating a command called docker volume create my data. Docker volume create my data. If I do docker ls, uh, sorry, docker volume ls means list. Okay, first command is like docker volume create my data means you just giving a name for the data, and then you see uh, two things are there. So even the store I actually not given here, but it somehow took the store, uh, the physical host as a mount directory here, and now one more directory or local volume has been created is called my data. Okay, now if I do docker ps. I have something here, like let me uh, delete that. Now what I will do, now I know I have a volume now. Now I will do like do the volume mounting in the run command. Now if I go, instead of store, I will give it as my data, because that is what the volume I have created. Docker run hyphen d hyphen p hyphen v is equal to volume mounting. My data is the volume I created, and under slash store, it should have some files get stored. Those files I needed here. Execute here. Okay. Now I go. Now I go inside this container. Docker exe hyphen it. Uh, Now if I go to store folder, I create some file. See, in LSF and LTR, in the slash app slash store folder, I have actually created a file called demo.txt, and the demo.txt file contains the allo group content. Okay, so if I stop this container, if I do docker ps, if I do docker rm hyphen r, and then delete this container id and run the container back again. If I go to this inside this Docker container, I will be still able to see the file. Oh, sorry. Hmm. You see, what I did is like, uh, after I created this demo.txt file, I came out of the container, and then I stopped the previous container using docker rm-i rf, and then I started to run one more container with mapping the same my data, because we have some file in the slash app store folder, and it's mapped to my data. That is the volume that we have created. So after I killed the container, I started to run with doing the volume mode, still the file exists, and you can still see the content as demo.txt. So that's the use of docker volume, because docker contents are always ephemeral. If you want to store any um, like data or something, then you should use the docker volumes. Okay, so docker volume inspect is to just inspect. If I do the execute the same command. If you do inspect, you will be the same thing like what we did, like docker inspect and the container id and container name, it will give some json file, right, with some details. The same thing it will be going to generate. So currently the mount path is like where lib docker volumes my data under slash data. That this is where actually the file is present in the system library. You don't need to know this thing, you just know the command docker volumes. I don't want this volume, I want to delete this. First, for in order to delete that, I have to delete my container or my fun or, and then I delete my container, and then I delete my volume, because volumes is mounted to the container, right, so it will throw an error. So that's the reason my data volume has been deleted. If I do docker volume ls now, I should not see any volumes. Yeah. I hope you got it. And then mm, that's what I want to talk about Knocker network. Okay, so networking. So so I just wanted you to be aware about these things, but we are not going to see anything here, like because nobody is going to use these things in the real time as well. Just you have to know something. So by default, all the networks, all the Docker containers that you deploy in the environment, it always goes to this bridge network. What is this bridge network? Bridge means it's a single point where all the Docker container comes. So if in your Docker container, if you have multiple containers and you start to run the multiple Docker containers, one container need to talk to another container. Okay. Okay, this is one container, this is one container. Okay, this is your VM. Okay, Docker 1 and Docker 2. Okay, so it is in the same VM. By default, if you don't do any isolations, so the Docker 1 can talk to Docker 2 and Docker 2 can talk to Docker 1. So this is how the default behavior of Docker looks like. So that's what Docker networks allow containers to talk to each other, isolated by default but customizable. So it is isolated, but you can do some customization isolations if you need it. Okay. um, See, uses bridge for mostly it is uses bridge because all the things are in the same networks. So suppose if you want to do some segregations here or something, then you do the same thing. But however, we created the things, we are going to do the same thing. We are going to do some Docker network create mynet. Any name you can give. Yeah, okay, it's not the same name you can give. You can give some other vnet. I'm just giving vnet docker something. I'm giving like you see, now if you do docker network ls means list. You see, by default this bridge and host is there. uh, these containers that we created, vnet and vnet bridge locals are we created. Okay, so if you want to do any segregations, if you don't do any segregation, like all the containers will going to be this one, this bridge network. These two networks we created now, like the name is like mynet and vnet docker network, we created it. So if you have any like applications like need to be run here in the separate network, then in the hyphen network you just specify the network before you run the container. Okay, that's the use of this docker networks. You don't need to be concentrate much here, just aware about these commands and what are the networks that used in the docker. So by default, like there are five types of Docker networks are available. One is bridge. Bridge means it's separate environment where your 1 second. Sorry, 1 second. I'm having a water. Okay. So first, you first try to remember this three. So um, mm, So there are like, as I said, like five network types are available. The bridge is net. If you do Docker I don't have any container. Let me run some container here. I start running a container now. If I do Docker inspect and then the container ID, you will be seeing an IP address here, right? See, the IP address is 172.17.0.2. How this IP address has been assigned to this container and it's giving some gateway and all. So, like this IP address, whatever you see for the Docker container, is different IP compared to the VM IP. Okay, this 172 dot, like always remember, like most probably, um, throughout your DevOps lifetime, wherever you see some IP starts with 172, and then some IP starts with 196, uh, and then some IP starts with 10. Okay, these are always going to be internal IP. All this series has been allocated for the internal IP. Most probably, this whatever, if you see an IP address with starting with 172, 196 or 10, it's most probably an internal IP. So what happened here is like, when I ran the Docker command, my Docker container got an IP uh, with 172 series. Okay, that is what the bridge network does. Bridge network, because you do a port mapping, right? So when I ran a command, what happened is like, so my application, if you try to access this 172 series with 5000 port, it will not work. Okay, um, because this is an IP that attached to the Docker container, and the Docker container runs with 5000 port. Your machine has different IP. That's why when you go and you go do localhost 5000, your application is working. You That is the bridge network, because here your host, like, here your host and Docker containers are separated. Okay, it has given some 172 digits. It will have separate IP for the host, and Docker container will have different host now, like IP address. And I do the port mapping like 5000, 5000 to 5000 here, from the physical host to the Docker container. That's how the bridge network works. If you create some Docker container in the host, if you create in directly in the host, means what happens here, like, here in my laptop I don't know the current parameters, but in the AWS, if we create, but mostly nobody will try, just learn, have it in the conceptual wise. When you create an Docker container in the host network, what will happen? As similar to your physical machine got an private IP address, your one more private IP address will be assigned to your machine. Okay, not inside the inside the VM, outer in the image. Consider a VM as a layer. In the outside layer itself, you will get a one more IP for your Docker container. By using that like IP address, you can access the Docker container directly. So this is for like, um, instead of, you don't want to have this bridge network, I don't want to do this port mapping, those times you have to use the bridge network. So, and if you want to like run your container without no network, means you should use as none type. um, that is called Docker none type. Okay, if you create a network with none type, and because none type means, my container has to run, and it has to do some functionalities, but there is no need for it to communicate to the outer world. Those times you use the none. So this overlay and McLaren overlay, it's actually used in the Swan. Swan means like, there is something called, I don't want to give much of the details. There is something called, similar to Kubernetes, there is something called Docker Swarm. If people ask you that you worked on Docker Swarm, straight away tell, I didn't work on Docker Swarm, because nobody in the real world uses the Docker Swarm. It's just a it's there, but nobody uses this thing. So in the Docker Swarm, what we do is like, it's a master node. You have to do, yeah. You were asking anything, Sir Lokesh? Lokesh, you're speaking something.
Can you?
Lokesh.
Uh, yeah, just now only I can see the image. About the nun you said, na?
Ah,
Nun.
Yeah, yeah, about none. Okay, so this is my VM, right? I'm running a container inside it. I don't need to assign. any of the private IPs to the Docker container itself. Those type you will be creating a Docker network none, and then while running the Docker container or running the Docker run command, you specify the hyphen network is equal to none. You just need to specify the hyphen network is equal to none. Okay, you no need to like create also. If you specify hyphen network none means previously what happened, like a private IP has been assigned here, right? A private IP has been, right? When you do none type, no private has been assigned, and this container will not be able to talk to internet. No inbound and outbound rule can become. Only whatever the job that you assign for this container that will do here. Okay, so these are like conceptual wise. We are not going to do any demo class. You just remember it. Um, and the next concept will be Docker Swarm. In Docker Swarm, what they will do is like they because we cannot handle a load in a one single VM. They will going to add some couple of more machines, and then they group together, and they distribute the load. This is how the Kubernetes will also work. They have the master node and they will have the worker nodes. But this configurations that the setup everything as you do the manually, then that is called Docker Swarm network. But when you do installation of these things, Docker Swarm setup and all. One second, I'm running out of battery. Mm, 1 second. Okay. Uh, you can hear me, right, Lokesh? Still.
Ah, yes, yes, yes.
Okay, I think my mic got disconnected. I hope it. Uh, so that's where this Docker Swarm has been used, and this Meclan means it actually used in the Mac laptops, like similar to host that we can use this thing in Windows and mostly in Linux it will work. Similar to that. Um, Similar to that, you will be using the McLaren, but you no need to like do some practical things. You just need to keep remembering. So if it's like if you want to create any of the bridge network, apart from the default one, you create that and Docker network create thing. It will create a network for you, and then in hyphen network you just specify it. If you want to do in the host, in a direct hyphen network, you have to specify it as hyphen network host. If you don't want like any network, then you will specify hyphen network none. So I hope you got it here. So you don't need to much concentrate here. I just it's like you theoretical or something, you have to know it. If like somebody would ask like, is there any way instead of the default bridge network, would you create containers in separate network? Those times you have to explain, yeah, that's possible. We are using like Docker network commands. At that time you can explain about bridge host and if they asked. uh, I hope you got it. So let's move on to the next comments. And yeah, so mm, mm, let's move to some advanced comments. um, if you do ls upon ltr, uh, it will not work here. Okay, if you do ls, if you do ls here, I'm actually in the Phoenix project. You only see these files, right? But there is a container running, right? Docker ps. If you do container, if you do go inside that container, I execute like an hyphen it and then inside the container slash bin slash bash. Okay. Oh, fuck. It's a shell issue. Okay. You can use the CMD here. See now inside the container, if you do LSF and LTR, there is no files here, right? Because I even mapped to the store folder or something. It's running in the folder image here. What I do is like I create a file called test file. Okay. I create a file called um, test file. See, I create a file called test log file. If I do ls file enter inside the container, this test dot log file is there. If I check for uh, the content is test file. Okay, I'm coming out of the container. If I do docker ps, the container is running. I know it. The test dot log file it exists in the in the slash app folder, but I want the file need to be copied to my physical to this Windows machine. Then you will be using the command called docker cp command, and then you give the container id, and then colon slash app slash test dot log file, and then dot means current folder, docker cp, and you give the container id colon and the directory and the file path and space and current directory. If you do that, what is a successfully copied uh, the file to here. If I type c, if you see test.log file is copied here, test file came here. So that's the use of this docker cp command, and reverse versa it's also possible. Either in the docker cp from the from your local also you can copy to the docker container. From the docker also you can copy to the you can copy to the local. Okay, both are possible. And we were seeing this docker uh, execute command uh, to go inside the container. So and one more container like command is the like so you want to see how much cpu and memory is been used by you has been used by your container, then you use docker top. If you do use docker top uh, re- and then you give your container id, you see it printed like what is the process that has been running. So it will just give you what's the process has been running, and how much of cpu and memory has been utilized in the docker container without going inside the container. If you want to see this, then use the command called docker top. Okay, that's the use of to view the process in your container. You use the docker top command. If you want to use if you want to check for like the cpu like memory and cpu things, then you use the docker stats. If you use docker stats, that is fine. So like a window will be prompted for you. So it will list all the containers that are running and how much of cpu and memory is being used. cpu is like 0.01 percentage is used out of 3.5 gb. It is just using 19 point MB because it will take all the limit for me in the current folder. That's why it's huge here. And then if you do control c, you can come out of the shell. Okay, that's docker top is to like view the process that running inside the container. You can do two ways. You can use docker exe and go inside the container and then do docker ps. You can do this top command or some top commands to see the command, or you can do directly use the docker top command. The docker stat is to like view the cpu and memory, and we already seen that docker inspect container id. uh, it will give you the JSON data where we were seeing this mount details, IP address, application status, everything you can see. And then bind, we already seen how to we bind to the physical host instead of creating Docker volume. How we can bind the host, those also we have seen here. And then it's just a reset policy. It's just an additional argument. While you run the container, if you give hyphen restart is equal to app is equal to always. If the application right now also you can run. But what will happen is like read the line like auto restart policy. If your container is going down and you want to restart the container, you should give this command. Okay, docker run -fn restart is equal to always, because sometimes when the application has been running, if you type docker ps, uh, so remember this thing carefully, like if now your application is running, there is no nothing here like status is 50 up to 15 minutes and created 15 minutes ago. Now it's actually running. So sometimes some app crash issue can happen. Remember the word app crash. If application is running, if something happened to the application, then some issue will, like a print will be popped up like app has been crashed. In those time, if you want to then that time you cannot access the application from browser on the port number, right? So if in that time, if you set this parameter like -fn restart is equal to always, if the app crash has been happened, the application will start automatically and it will run. So that's the use of this argument. So the last thing would be like docker compose. I would have some let me use this thing. um, uh, so let me go to ChatGPT. Okay, let me come here. So what is this docker composing means? Like, um, let's try to wind up as fast soon as possible. This is one container. This is one container. Each and every time, do you think I can run these containers each and every time by using docker run command? That will be difficult for me to maintain the containers, right? So consider like a product. This product needs multiple microservices that need to be run, and it has been and all the microservices need to be run, so it can be served to the end user here. Okay, there will be end user that will be consuming it. If any one of the application goes on, that will be difficult for the user to access, like get some information from the application. So that's where this docker compose comes. Docker compose is just an like an the word itself says like compose means you compose whatever your application need. Like for your entire project, how many applications you need, you specify this information in a YAML template. We will see what is this YAML files and all. YAML, it's a template. Most throughout your DevOps thing, you will be seeing this YAML file, dot YAML file, like the dot .txt file. You will be seeing an YAML file. YAML file has its own syntax. The you should like list and dictionaries. So we will be specifying the details in the YAML file, and then if you do Docker run, that all the applications that is specified in the Docker compose will run. And then if you do Docker and if you do docker down, and then application should be down. Okay, so like I have a sample docker compose file here. Let me take this file and go to my file and then create a one file called docker compose dot yaml. Okay, YAML file. Okay, you should remember, you can give it a YML or YAML, both are fine. So what I mentioned the version as 3.8. So these are, don't, why you are mentioning 3.8? This is a template. Okay, this is just a template. So in this template, what happens here, like um, Uh, so in this template, the version 3.8 is just points to the Docker Compose version. Okay, it's just a template, and that inside in below you will be having service. In below that you having two sections. This two sections means two microservice. That's the meaning of this one. Okay, uh, you have an image here, nginx, and the port is like the 8080 is on the physical host, and this ID on the container level, and you have one more application called API, that image, the working directory, and you should set a volume for it. So you will be specifying all the details, because I can use the docker run command, right? Like we used before. Mm, so you have to, whatever the details that you specify in this command line, you've been just specifying here. You see, you specify like hyphen p 5000 5000, you specify the ports here, you specify the image here, image tag here, and whatever the working directory you need, whatever the command that you have to execute, those things and all you will be specifying here in the Docker Compose file, and then you just simply uh, do Docker. I don't think compose Docker Compose I have installed it. I have to install it. But you can remember this thing. And once you have have the commands, you just do Docker Compose hyphen up, then it will be start running for you. So I don't have the Docker Compose here. Oh, it's there. Okay. Docker Compose up is there, right? See, only I specified like version 3.8 service. So these are template things. Okay, these two are template. You by default you have to put in there. Like how you for loop or if loop you have some conditions. It's a file format throughout your DevOps cycle. It will be like this only. You specify the web application name and the API application here, and then you give whatever the information that you pass the command line, you pass it here, and then you do Docker compose up. So the by default the file should be like docker compose.yaml. If not, you have to specify the file. Now I'm typed the file. Now what is this doing? Like uh, I'm not building the image, okay? I'm just running the command, okay? Building is Docker build is different, Docker run is command different. So if I have multiple microservices, and that I will be using this Docker Compose deep to serve these things. Now I know my Docker things are running. If I do Docker PS, now if you see, like Nginx has been started to run and is running on the 8080. Uh, and obviously you see like sorry. Sorry, I messed up something like if you see, sorry, it's actually I didn't run it in the background. If you do Docker, mm, mm, I from what I told hyphen demons in the detached mode that is in the background. Okay, foreground means in front of that. Before I didn't specify for D. That's why if I after I doing Control C, the application came out. Now I am doing the Control D again. Now you see both are started. Um, if I do Docker PS, obviously it will fail if I do like because it needs some uh, index.js file. And all. We don't have the file in the local. That's the reason it has been failing. See that node is being exited about a minute. If you do Docker logs, um, if you, this is how you should expect. If you see that it's like exited, it's not running. If you do Docker logs, then you know what is throwing error. Node.js because cannot find module app index.js file because we don't have the jx file and we never copied it to here. That's the reason it's been not running. So that's how you do like Docker compose up, and then you do Docker down, compose down, and then remove. If you do Docker ps now you will not be seeing those informations itself. See, that's the use of this Docker to have multiple applications that are running there. You can use Docker Compose PS means only the application that ran by the by the compose file that you will be able to see. You will not be able to see these Phoenix things. Only the applications like web and API which is triggered by Docker Compose that you will able to see when you are in the Docker Compose PS. Uh, any doubts that we are completing Docker today? And